So the next chapter is chapter 6, lines and angles. So lines and angles, many of the concepts you have done in class 8 and some of the concepts are new, definitely. So we are going to go through this, right? Lines and angles. So if I go through the introduction, it will help us in solving the questions. So first of all, we should understand what are the different types of angles. So if you see, the first one is acute angle. The acute angles are angles which are greater than 0 but less than 90. So anything which is greater than 0 and less than 90 is called an acute angle. An angle which is exactly equal to 90 is called a right angle. And angles which are more than 90 but less than 180 is known as an obtuse angle. And here we have a straight angle which is equal to 180. Anything which is more than 180 and less than 360 is called a reflex angle. And of course, if it is exactly 360, that is called a complete angle, right? So acute, right, obtuse, straight angle, reflex angle, and complete angle, that is full 360 degrees, right? So these are the different types of angles. So once we understand the different types of angles, we can move further to the next part, that is what are complementary angles and supplementary angles. So if you see here, the word complementary is mentioned here. Complementary angles are angles which add up to 90. Two angles which add up to 90. So I can say 30 and 60 are complementary angles. 45 and 45 are complementary angles, right? 85 and 5 are complementary angles. So any two angles, there has to be exactly two angles whose sum is 90 is called complementary angles. And two angles whose sum is 180 is called supplementary angles. 110 and 70, 180, 170 and 10 are all examples of supplementary angles. So these are complementary angles and these are supplementary angles, right? So we should understand the difference between the two. This is adjacent angles and linear pair of angles. What is adjacent angles? Now, if you see these two angles, it is characterized by two things. One is a common arm, right? BD is common to both. So this is the common arm, right? BD is a common arm and we have a common vertex. So these are called the vertices and this is the common vertex. So we have a common vertex and a common arm. So one angle is angle ABD, right? This is one angle here. And the second angle is DBC. We can say that they are adjacent angles. Why are they called adjacent angles? Because both the angles have a common vertex and a common arm, right? This is the common arm and this is the common vertex. So we have angle 1 and 2. These are adjacent. If they are not connected, then they are not adjacent because there is nothing common. No common arm, no common vertex, right? Then we have linear pair. Now, what is the meaning of linear pair? Linear pair means when you have a straight line, the two angles add up to 180. So this angle ABD and angle DBC are called linear pair. So whenever we have a straight line and we have two angles lying on it, then these two angles will always add up to 180. This is called linear pair. This vertically opposite angles, whenever we have two lines, here we have two lines AB and CD intersecting each other, then we have vertically opposite angles. So here we have angle 1 and 2 vertically opposite and angle 3 and 4 are vertically opposite angles. And the proof of this is important. It comes in the exam. Prove that vertically opposite angles are equal. So we will be doing the proof shortly. So intersecting lines, and the opposite of that, non-intersecting, that is parallel lines. Parallel lines will never intersect even on extending indefinitely, right? So having gone through this, we will go through the next one, that is the proof. So let me take out the proof of the vertically opposite angles equal, right? So this is our theorem, theorem 6.1. If two lines intersect each other, then vertically opposite angles are equal. So the proof is quite simple. What we need to do is draw two intersecting lines as given here. AOB and COD are intersecting lines. Now, if you take these two angles, we have to prove that angle AOD is equal to angle BOC. So the proof is very simple here. Angle AOD, if you look at angle AOD and angle BOD, they are linear pair. So angle 1 and 2 are linear pair. So 1 plus 2 is 180. And if I take angle BOD and BOC, that is angle 2 plus 3, that is also 180. Both these are by linear pair, right? Just now we understood what is linear pair, angles on a line. So 1 and 2 adds up to 180, 2 and 3 adds up to 180. Therefore, I can say that 1 plus 2 is equal to 2 plus 3, and 2 and 2 is getting cancelled. We know that if there is something common that will get cancelled, then we will get angle 1 equal to 3. Therefore, we can say vertically opposite angles are equal. The same thing I can repeat if I want to prove 2 equal to 4. Same thing I can do here. Angle 2 plus 3 is 180, again by linear pair. 3 plus 4 is also 180 by linear pair. Therefore, I can say that 2 plus 3 is equal to 3 plus 4. And 3 gets cancelled. And therefore, we can say 2 is equal to 4. So this is the proof that vertically opposite angles are equal. So please remember to learn of this proof, because this theorem can be asked in the exam, right? Next, we go to the questions. So let's start with the exercise 6.1, the first question. Figure is already given to us. And if you notice here, some information is given to us, that is angle AOC plus angle BO is 70, angle BOD is already given 40. And the question is find out angle BOE and reflex of angle COE. There are two things we have to find out. The first is find angle BOE and the second is reflex of COE, right? So here we have the information given. 40 degrees is given here, angle BOD, therefore vertically opposite angles are equal. So we can say that angle AOC will be 40, right? So angle AOC is equal to angle BOD, that is 40. Why? Because they are vertically opposite angles. Just now we understood the theorem and we know what is vertically opposite, right? So these are two intersecting lines and therefore these two are vertically opposite. So we can say that angle BOD is given 40. So angle AOC will also be 40, right? Now we go to the next piece of information, that angle AOC plus angle BOE is given 70. This is already given to us. Now we have already found out the value of angle AOC as 40. And therefore we can replace here the value of AOC as 40. And therefore what happens? Angle BOE will be 70 minus 40. That will be 30. So we've got angle BOE as 30. Now we attempt the question that we have to find out angle BOE that we have found out. Now the question is find out reflex of COE. So this is angle COE. So how do I find COE? If I look at this, this is a straight line. AOB is 180, right? AOB is 180. So all the angles together here will add up to 180. So these two are already found out. So what can I do? I can add the three angles and I can say that their total is 180. So I will get angle AOC plus angle COE plus angle BOE as 180 degrees. Angle AOC is given 40. Angle COE is what we have to find. And angle BOE I have just found out as 30. Now 40 and 30 is 70. It will be transferred to the other side. So we can say 180 minus 70 will be angle COE. So COE value will be 110. Now the question is find out reflex of COE. So what will be reflex of COE? Reflex of COE will be 360 minus 110. So whenever they are asking us to find the reflex angle, remember, you just have to subtract that angle from 360. If you remember at the introduction of the chapter, we said that reflex angles are angles which are greater than 180 but less than 360, right? We go to question number 2 now. So here we find figure 6.14. XY and MN are lines intersecting at this point O, and angle POY, this is already given to us as 90 degrees. A and B are in the ratio 2:3. That is a ratio given. We have to find out angle C, right? This is the question. So whenever we are having a ratio, we will say let A be 2x and B be 3x. It's in the ratio 2:3. So it can be in multiples of 2 and this can be in multiples of 3. So we assume whenever there's a ratio, we assume 2x and 3x. Now, if you look at this 2x and 3x and this 90, they all together are lying on this line XOY. And we know that this is a straight line, therefore this will be 180, right? Angle XOY is 180. So I can say that A plus B plus 90 is 180 angles on a straight line. So A value we have assumed 2x, B value we have assumed 3x, plus 90 is 180. So 90 gets transferred here. So we get 180 minus 90. So we get 5x is 90. Therefore, x is 90 upon 5. So that becomes 18. So x value is 18. So what will be the value of A? A will be 2 into x, that is 2 into 18, 36. And the value of B will be 3 into 18, that is 54. And the question is find out angle C. If you notice, this B and C together form a linear pair. So B plus C is 180. B we have found out as 54. So 54 plus C is 180. So C will be 180 minus 54. C will be 126. Moving on to question number 3, figure 6.15, the interior angles, angle PQR and PRQ are already given. So these two angles are already equal. So angle 1 and 2 are already equal. Question is, prove that angle PQS and PRT are equal. The exterior angles have to be proved equal. So 1 and 2 are equal and we have to prove 3 equal to 4. So very simple here. Angle 1 and 3 together form a linear pair. So their total is 180. Same with 2 and 4. 2 plus 4 is 180 linear pair. Right? And therefore, I can say that 1 plus 3 is equal to 2 plus 4. And we are already given this information that 1 and 2 are equal. So 1 and 2 gets cancelled. Therefore, we can say that angle 3 equal to 4. Or in other words, angle PQS is equal to PRT. So this is question number 3. Then question number 4. X plus Y is equal to W plus Z. We have question number 4. X plus Y is W plus Z. Prove that AOB is a line. Now, in order to prove that anything is a line, we need to prove it's 180. So what we can do is add up all this. X plus Y plus W plus Z is 360 because it's a complete angle, right? When we add all these angles together, this is going to form a complete angle. So this is 360. Now, this information is given to us that X plus Y is the same as W plus Z. So what we can do, let X plus Y remain as it is. Instead of W plus Z, we can replace it with X plus Y. All right, we can replace W plus Z with X plus Y because it's given that X plus Y is the same as W plus Z is equal to 360. So we have now 2x and 2y giving us 360. Take 2 common, we get 2x plus y is 360. Therefore, x plus y is 360 upon 2. So x plus y is 180 degrees. And what is x plus y? It is angle AOB. So we get angle AOB is 180 degrees. And if we prove that any angle is 180, that's a straight angle. If it's a straight angle, that means it's a line. Therefore, we can say AOB is a line, right? Then we have question number 5 and 6, very important questions. POQ is a line, OR is perpendicular. That means this is 90. OS is another ray line between the rays OP and OR. Prove that angle ROS is equal to half of QOS minus POS, right? So in order to solve this, what I will do is I will start with the initial information that is given to me that OR is perpendicular to PQ. If OR is perpendicular, this is 90 and this is 90, right? Because this is a straight line, linear pair. So I'm going to start with this information that angle ROP is equal to ROQ. Both are 90 degrees because OR is given perpendicular to PQ. If it is perpendicular means it's 90 either side. So ROP and ROQ are equal. Now, if you look at ROP, it is made up of two angles. One is ROS and the other is POS. So instead of ROP, I can replace with ROS plus angle POS, right? This is a bigger angle. Instead of ROP, I'm going to split it into two parts. Look at the figure. ROP is ROS plus POS is equal to ROQ. Now look at ROQ. ROQ can be written as, there is nothing inside, but ROQ can be replaced with QOS minus ROS. The reason being, we want in terms of the question. So the question, in the question, there is QOS and ROS. So I have to replace the value of ROQ in terms of what I need. So ROQ can be written as QOS, that is this big angle, okay, ROQ is QOS minus this small angle which is inside minus ROS. So this was simple. ROP is ROS plus POS. Here we'll have to little bit rack our brains. ROQ is QOS, this bigger angle, this obtuse angle minus this small angle ROS will give us ROQ. So we have done this. Now all you have to do is bring ROS on one side. So we get ROS. This is minus ROS. We shift it to the left side. So we get ROS equal to QOS minus POS. This is twice of ROS is equal to QOS minus POS, right? When I shift side, remember to change the side. So ROS I have brought here. So that has become positive. This POS I have shifted to the right. That's why this has become minus. Therefore, we get the required result. ROS is, this 2 will go down, half of QOS minus POS, which is the required result, right? ROS is half QOS minus POS. So you can note down this and mark this important. Similarly, with question number 6, now this is also important. The figure is not given. Angle XYZ is given 64 degrees. So this angle is 64. XY is produced. Now the meaning of XY is produced means I'm extending it. If I extend it upwards, that is YX is produced. This is XY. Direction is downwards, X to Y, right? XY is produced to a point P. YQ bisects ZYP. YQ bisects ZYP. Bisects means division into two parts, two equal parts. So YQ bisects ZYP means this angle is divided into two equal parts. So I'm taking it as X each. Now, this is a straight line. XYP is a straight line. So I can use angles on a straight line add up to 180. 64 plus X is 180. Why is this XX? Because it is given that YQ bisects ZYP. So 2x is 180 minus 64. 2x is equal to 116 degrees. X will be 116 by 2, 58 degrees. So value of x is 58. Now the first part is find out angle XYQ. Now what is angle XYQ? XYQ, if you look at the figure, is 64 plus x, right? It is 64 plus x. This is XYQ, 64 plus x. So angle XYQ is 64 plus x value we have found out here 58. So angle XYQ will be 122 degrees. So this is the first part. 64 plus 58, right? This is going to be 122 degrees. Second part, we have to find reflex of QYP. Now QYP is, from the figure, QYP is x. And we have found out the value of x as 58. Therefore, reflex, I told you, is whatever is the angle subtracted from 360. So 360 minus 58, that's going to give us 302. So this will be the answer number 6. XYQ will be 122. And reflex of angle QYP will be 360 minus 58. So that's going to be 302. Reflex of QYP, right? Reflex. So QYP was X value was 58. Subtract 58 from 360, we get 302. 6.2 question number 1, AB is parallel to CD and CD is parallel to EF. Okay, so when two lines are parallel to the same line, they are obviously parallel to each other. This is given to us. So from here, we can also say that AB and EF are parallel, right? Two lines parallel to the same line are parallel to each other. So AB is parallel to CD, CD is parallel to EF. So AB and EF are parallel. So all the three lines are parallel. Now Y and Z are in the ratio 3:7. Find X. Now in the previous exercise, I told you, whenever there's a ratio, take it as 3x and 7x, but here there's an X value. So let's take something else. So let Y be 3a and Z be 7a. We will not take X because already there is a X term here. So there will be a confusion, right? So Y and Z, we are assuming as 3a and 7. Now, if I look at Y here and Z here, what is the relation here? At the moment, we don't see the relation, but what we can do is that these are vertically opposite angles. So if I look at this angle Y here and this angle here, these are vertically opposite. So I can say that angle 1 is equal to Y, and Y value we have assumed as 3A. Vertically opposite angles are equal, right? Vertically opposite angles. So angle 1 and Y are equal and Y is 3A. So 1 will also be 3A. And Z is already assumed as 7A. Now we know that if CD and EF are parallel lines, then the sum of the co-interior angles will add up to 180. So I can say that angle 1 plus angle Z is equal to 180. What was the reason? Sum of consecutive interior angles. Right? Sum of consecutive interior angles. So angle 1 is 3A. We have proved here. And Z we have assumed as 7A. So 3A plus 7A is 180. So 10A will be 180. So A will be 180 upon 10. So A value is 18. And the question is now find X. So we have found out A as 18. Now, if A is 18, value of Y will be 3 times A. So Y will be 3 into 18. So Y value will be 54 degrees. So Y value is 54, right? This is 3 into 80, 54. Now, once we know Y is 54, we know that X will be 180 minus 54. So we get angle X as 126. So value of X will be 126. So this is how we find X. Question number 2. Here AB and CD are again parallel. EF is perpendicular. So this is going to be 90. Angle GED. That means this entire angle is 126. Question is find out angle AGE. So here, since these two are parallel lines, AB and CD are parallel given, and this is the transversal, right? G is the transversal. These are alternate angles. So angle AGE will be equal to GED, that is 126, because they are alternate angles, right? So this is also 126. This is 126. This is also 126. It's like a Z shape, alternate angles, right? So this is the parallel lines. Remember, these are alternate. So whenever there are alternate angles, we know that they are equal. So this is 126. Therefore, this will also be 126. Second part, find angle GEF. That is this particular angle. So if I want to find this angle, from the bigger angle, I'll subtract 90. So this is 90. This bigger angle is 126. So angle GEF is 126. That is a bigger angle minus 90. So we get this angle as 36. So this angle, small angle here is 36. Next part, we have to find out angle FGE. This we can find out by linear pair. FGE is 180 minus 126. So why? This is a straight line. So when I subtract, I'm going to get this particular angle. So here the answer is going to be 54 degrees, right? Now we go to question number 3, that is PQ and SDR parallel lines. PQR, this angle is given 110. This is 130. Question is find out angle QRS. So here we can draw the construction, draw a line parallel to ST passing through R. So what I need to do is draw a line passing through R, and this line will be parallel. So hint is given in the exam. Obviously, this hint may not be given. So when I'm drawing this line parallel to the parallel lines, PQ and ST are already parallel. When I'm drawing this parallel, all these three will be parallel. So I can number these angles 1 and 2. So 1 will be 180 minus 110, that is 70 degrees, right? Because sum of co-interior angles add up to 180. And angle 2 will also be 180 minus 130, that is 50. So this angle, by using the property the sum of co-interior angles add up to 180, we can find out angle 1 as 70 and angle 2 as 50. Now the question is find out angle QRS, that is this angle in between. Let's name it as X. Now we know that 1 plus X plus angle 2, all these three angles will add up to 180 because it's a straight line. These three together will add up to 180. So we get 70 plus the unknown angle X plus 2, we have found out 50 is 180. So X will be 180 minus 70 and 50 will go that side 120. So X value will be 60 degrees. So therefore, I can say that angle QRS is 60. Then we go to question number 4. Question number 4 says that AB and CD are parallel lines. This angle APQ is 50 already given, and angle PRD is 127. Question is find out X and Y. Simple question here, X will be 50 degrees because they are alternate angles. Already it is given that AB and CD are parallel lines. So if they are parallel, this is alternate. So this is 50, right? Now we can use exterior angle theorem. Now we know that exterior angle is sum of two interior opposite angles. So exterior angle is the outside angle, right? So angle 1 is 2 plus 3. Exterior angle is sum of two interior opposite angles. So 1 will be 2 plus 3. So using that property, this is the exterior angle. 127 will be equal to X plus Y. I'm using this property. Exterior angle is sum of two interior opposite angles. Exterior angle property. Now 127 is X, we have already found out as 50. So Y will be 127 minus of 50. So when I subtract this, I will get the required answer 77. Question number 5. That's the last question. This is based on the mirrors PQ and RS are parallel mirrors. You see, this is shaded. This is the incident ray. This is the reflected ray, right? When a ray of light strikes on a mirror, it reflects. So this is called the incident ray. This is called the reflected ray. For this mirror, this is the incident ray and this is the reflected ray. Question is prove that AB and CD are parallel. So here, there is a law of physics which says that angle of incidence is angle of reflection. So this is called the incident ray and this is called the reflected ray, right? Incident ray. And there is a line, imaginary line called normal, which is perpendicular to the mirror, which divides this into two equal parts. This is called angle of incidence and this is called angle of reflection. This is in fact called the first law of reflection. What is that? Angle of incidence is angle of reflection. So we have to use this here. I am going to divide this into two parts by drawing the normal. So construction, draw BM and CN normals to the mirrors PQ and RS respectively. So as I said, angle of incidence is angle of reflection. So I can say that angle 1 equal to 2. And similarly here, if this is the angle of incidence, this is the angle of reflection, right? So this will be 3 equal to 4. So here we are using the first law of reflection. And what is that? I explained here, angle of incidence is angle of reflection. So 1 and 2 equal, 3 and 4 are equal. Now, as I said, BM and CN are normals. Normals are always perpendicular to the mirror. And we know that two perpendiculars, two parallel mirrors will always be parallel. So BM is parallel to CN because BM and CN are perpendiculars to a PQ and RS, which are parallel to each other. Okay, so this is a perpendicular, this is also a perpendicular, but they are perpendicular to parallel lines or parallel mirrors in this case, and therefore they will be parallel to each other. So BM and CN are parallel. If they are parallel, then we can say that angle 2 equal to angle 3. Alternate angles 2 will be equal to 3. Now, if 2 and 3 are equal, I will double this. Therefore, I can say angle 2. If I double it, I'll get twice of 2 is twice of 3. I'm going to double 2 and I'm going to double this because Euclid's axiom we did, double of the same things are equal to each other. If two things are equal, their doubles are also equal. So 2 and 3 were equal. So I've doubled it. Twice of 2 is twice of 3. Now what is twice of 2? 1 and 2 are equal. So when I double this angle 2, I'll get this full angle. And that full angle is ABC. And when I double angle 3, I will get angle BCD. And they are alternate angles. What are ABC and BCD? They are themselves alternate angles. And if I use the converse now, if alternate angles are equal, then lines are parallel. So I know that angle ABC and BCD are equal. So if these two angles are equal, then I can say that these two lines are parallel. So I've proved that angle ABC is equal to BCD. This implies that AB and CD are parallel. So here we get ABC equal to BCD, but they are alternate angles. If alternate angles are equal, then lines are parallel. So with this, we finish this chapter, lines and angles.